In this video, we're going to learn about a new Python data type called a tuple, which is very much like a list. We're also going to learn about the key difference between tuples and lists, which is mutability and immutability. So tuples, as I said, are very much like lists, and you define them in a very similar way, except you use round brackets instead of square brackets. In this first code cell, I've defined a tuple called mytuple, which has got length 3 and contains the three numbers 1, 2, and 3. I've defined an empty tuple, which we do with just a pair of round brackets with nothing between them, and a tuple of length 1, which we have to define in this somewhat strange looking way with a comma to make sure that it's not confused with function application or with just brackets used as punctuation. So there's that special case in the notation for tuples with one element. Okay, we'll run this code cell, and now those tuples are defined, and if we want to access the 0th element in a tuple, then we can use that using the same square bracket notation that we use for strings or lists. Just like strings or lists, the index starts with 0, so my tuple square bracket 0 refers to the first thing in that list, which is a 1. You can get the length of a tuple with len, just like for lists or strings, and you can concatenate tuples with plus, just like for lists and for strings. So the tuple 1, 2 plus the tuple 3, 4, 5 is the tuple 1, 2, 3, 4, 5. So let's now look at the difference, or the most important difference between lists and tuples, which is that lists are mutable, whereas tuples are immutable. To see what that means, let's take an example. In this code cell, I've defined a list called mylist, which has elements 1, 2, and 3, and on line 2, I assign to the 0th element of my list. So I set the 0th element of my list equal to 99. Line 3, because it's the last line in a code cell, is just going to display my list, and you can see that after I run this, I have changed or mutated my list by modifying its 0th element. This property, that after assigning a list we can then modify its elements, is called mutability. And it's in contrast with tuples, which are immutable. You can't change a tuple after it's been assigned. You can't change its elements, you can't delete its elements, and you can't add elements onto the end. Let's see an example of trying to do this. In the next code cell, I've defined my tuple to be the tuple 1, 2, 3, and I'm going to try to modify the 0th element of that tuple by assigning to it. As you can see, I get a type error. Tuple object does not support item assignment. So it's telling me I'm not allowed to change an item inside a tuple after I've defined the tuple. The tuple is immutable. Now that doesn't mean once you've defined a tuple, you can never make the name mytuple refer to something else. You can always reassign variables no matter what type they have. So if I want to create a tuple, which goes 99, 2, 3, I have to do that by creating a completely new tuple and giving it the name mytuple, after which my original tuple is lost. What you can't do is modify a tuple once you've created it. You can only reassign them. Now mutable variables can be convenient, especially if you're working with data that you need to update or change, but they can also be the source of confusion, and they can be the source of subtle errors which make your program hard to understand or reason about. In the next code cell, we have an example of this. I begin by defining two functions, one of which is called modify list and the other is called reassign list. Modify list takes an input lis and it assigns to the 0th element of its input, so it turns the 0th element into 1. Reassign list takes an input lis and reassigns that input to be the list which just has the element 99. So it's not quite clear what's going to happen when I call these functions with a list as an input. Will I change? So let's say I create two variables like I do on line 7 and 8 there, a and b, which are both equal to a list containing two elements which are both 0. Now if I call these functions with a and b as inputs, a good question to ask is, will a and b be different after those functions have been called, or will they be the same? So let's do it. You can see here that the line 11 prints out the value of a and b after the two functions have been called on a and b in lines 9 and 10. And what's happened here is that the function modify list has actually changed its input whereas reassign list has not changed its input. This kind of slightly confusing behaviour arises because we used a mutable data type for A and B. A and B were both lists. If you do this with immutable types, it would be impossible to create this kind of confusing behaviour. This kind of behaviour where a function actually changes the environment in which it's running, so changes the value of the variable A, is called a side effect. Side effects are where functions can modify the program environment, the environment outside that function. On the other hand, functions with no side effects are called pure. Those kind of functions can sometimes be useful because they can do things which you actually want to happen, but they can also be the source of confusing bugs in your programs. This kind of thing is beyond the scope of MATH0011. If you like, the only thing you can take away from this is just to be careful when using mutable variables. But if you do want to learn more about those issues, there are 2 links there in this notebook, which I will post on Moodle. So actually, most of the data types we've met so far in Python are immutable. Strings, numeric types like integers or floats, and tuples are all immutable. The only mutable data type we've met so far is the list, but in a couple of videos' time, or perhaps even in the next video, we'll meet a new data type called a dictionary, or dict for short, which is also mutable. I'm going to end the video with another confusing type of behaviour which can be caused by mutability. In the final code cell, I create a list A whose elements are 1, 2, and 3. I then create a new variable B which is equal to A. So I assign to B the value of A. Then on line 3, I modify B by assigning to its 0th element. So after I've done this, what is A going to be? This is quite a unpredictable question because you can make 2 different arguments. You can say, well, I haven't changed A, I've not made any explicit assignments to A, so it should just be the same as it was. Or you could say, well, B was equal to A and I've changed B, so actually A must be changed as well. And in fact, that second argument is the correct one. So when you take the variable B and you define it to be equal to A, you're making A and B both point to the same object. And when you change that same object which they both point to, then asking for A will give me the same thing as B, which is a new list with a modified 0th element. So again, this can only happen with mutable variables where you're able to modify them after you change them. This is a further reason for which mutable variables can sometimes produce confusing behaviour.